So we are again looking at the bias variance trade-off in this video series. And so in the first part, we loaded in the data, and then we looked at the model that had high bias, which was our dummy regressor. And now in the most recent video, we looked at the model that exhibits high variance, which is decision trees. So in this one, I'm going to kind of show you what a Goldilocks model would look like, i.e. one that doesn't have too much bias or too much variance, but just kind of in the sweet spot between the two. And so for that model, for this data set is going to be linear regression. Now, a quick little caveat before we start coding. I'm not saying that linear regression is the Goldilocks model for every single data set. It just so happens to be for this particular data set, decision tree is the way to go. And so we'll see that here, but as it is with every new data set, you would have to kind of do some experimentation to kind of see what is the best model for that particular data set, okay? So getting started here, what I'm going to do is we'll create a list of linear regression predictions, right? So we're just kind of following the same steps that we've been doing in this getting very ugly for loop here. But you know what? It's good enough for government work, so we're going to keep going with it. So we have LR is linear regression, and we'll do LR fit, LR predict, and then down here we've got our LR predictions. Okay, so we've been doing the same step for all three of these models. We build a model, we fit it to the sample data that is was set up for this particular iteration in the for loop. We get our prediction, we add it to our list. Okay, so just like the other ones, we're going to create a histogram with these predictions. Okay, so what I'll do is PLT hist, and then we'll do LR predictions, and I need to make these a different color. So I think I'm just going to make them black. Okay, so in running the cell, we now have our third histogram of model predictions. And so it's this histogram right here, the black one, and that is our linear regression model, okay? So you can see that this model exhibits characteristics that are both bias and variance, and yet it's not too much of either, okay? So yes, the models does have bias in that every single model here is consistently wrong in its prediction on the target, okay? And so we see that here, every single linear regression model is under guessing the target, but it's not as bad as the dummy, right? So it does have bias, but it's not as bad as the dummy, okay? So by increasing the model's complexity, by going from something that just predicts the mean to something that actually has some heft behind it, we have decreased the model's bias, okay? Notice at the same time too, that this histogram does have variance, but ironically enough, it's actually less variance, I think, than the dummy regressor. So not only does it have less variance than our decision trees, but it's smaller than the dummy. So we've got a model that's got a little bit of bias, a little bit of variance, but overall the total error is probably less than all the other ones combined, okay? So hopefully this was a good kind of intro into the bias variance trade-off. Again, the trade-off here is the model's complexity. So as you increase the model's complexity, you run the risk of increasing the model's variance. And then the other side applies as well. As you regularize your model, which is to simplify the model, in other words, you increase the model's bias while decreasing the variance, okay? So you have this trade-off, but again, as you can see here, it's not a zero-sum game. So you can decrease the model's bias without increasing an equal amount of variance, right? So it's just kind of a sweet spot, and it's gonna be different for every data set, okay? So hopefully this was beneficial to you. I wanted to kind of offer the coding perspective to look at this particular problem with Python. But again, credit where credit is due. I didn't think of bias variance trade-off in a vacuum. I learned it, right? With a lot of great teachers out there, and so I'd be remiss if I didn't, share that with you. So Intro to Statistical Learning, there's a PDF version of this, I believe, is free. I don't know if it's changed with the second edition, but I know the first edition is out there somewhere for free. And again, this YouTube by Ritvik Math is also a great sort of explainer, goes into more of a conceptual one using the whiteboard here. So take a look at both of those to round out your perspective on this. And hopefully this was beneficial to you as well. Obviously, I'm kind of assuming some baseline pandas and scikit-learn and things like that. So, if you had that under your belt, hopefully this was beneficial for you as well.